Okay, we're gonna try again. I know this is crazy and this is how our lives are right now. They're a little crazy, but we just have to be patient. We have to learn from our circumstances. We have to be thankful from our circumstances because we also have to think that this is something that is abnormal for us, that we usually have very good internet, very good access. We have a great school to go to. So I know it's challenging, but let's do it, okay? All right. So we're going to finish around 10. So we have another 15 minutes. Okay. And then if you want to do a Hangouts call, we can also do that later after that. Okay. But right now, we're going to finish with these exercises. Okay. We're not going to be able, obviously, to cover everything. But what I'll do is that I'll just record these videos and I'll send you the links so you can see. Okay. So in this exercise, we said that the final answer was -3. And we said, okay, yes, this works because it's an odd integer. And so my final answer, that's what we were writing in the other email where we got cut off, is -3, -1, because remember we're going towards the right. So the next number after -3, or a bigger number after -3 is -1, 1, and 3. And so that's my answer, okay? Remember, your answer always has to be as a set, which is your solution set, okay? Excellent. All right. The next one we are going to do of lesson 82 is number 7. I think number 7 is something that is a little challenging still. So we'll learn it so that it's not challenging anymore. Okay. And hopefully we can have 15 minutes with no problems with internet so we can finish our class well. Okay. Number 7 says, if f of x equals x squared plus 1, I think plus 1, let's see. Yeah, plus 1, find f of x plus 1. Okay. And so these, even though it looks a lot like this and it looks confusing because it has an x, that is your, let me bring it up a little bit. That is your x. That's what you're going to have to evaluate. If the question, let's say this is A, if the question would have been find f of 5, what do? We substitute, right? So it would be f of 5 equals 5 in parentheses square plus 1, which 5 squared is 25, plus 1. Everyone knows how to do this one, I know. Okay, so that one you have it down. You know how to do that. Okay, but the question is, how is it? So you all know how to do this. If you just have a number and you have to substitute here, you evaluate and you find your answer. But what if instead of numbers, what you have is letters or an expression like this? Well, the process is the same. It's just it might be a little bit more, what can I say? I don't know. It's not complicated, but we're gonna still put my function. Remember, this is a function. It's like a machine. And so we want to change the x for whatever is inside the parentheses here. And what is inside of the parentheses is x plus 1. So that's what I'm going to change here, x plus 1. Okay? Now, this is the same as multiplying x plus 1 squared is x plus 1 times x plus 1. Okay? Now, I don't remember if we saw this in class or not, but there's a formula that is very easy for you guys to remember. And we're going to put it like that, okay? And we're going to say, okay, we're going to put, well, actually, it comes from here is the second thing and the third thing. Okay, so is the first one squared plus, and then we're going to multiply these two, x times 1, x times 2, so 2x, and then plus 1. This is always a plus, so we don't even have to worry about that. That's always a plus. And then here on the outside, we're going to put the square of these two numbers, so x squared and 1 squared. And then here is this sign, so this is negative, this is negative, this is positive, this is positive. And in the center, it's very easy. It's just 2 times the multiplication of these two. Okay, so x times 1, x times 2, 2x. And then we have to bring down this 1 and simplify. Okay, I'm going to finish it and then I'm going to explain 2 things before we continue. So we add like terms and 1 plus 1 is 2. So if I do f of x plus 1 in this machine, this is my answer. And that's it. That's all you have to do for that one. Okay? Now, I know that some of you, welcome, Pao. So good to see you. I'm glad you were able to connect. Okay, so some of you might say, but teacher, I thought that x plus 1 squared, I'm going to put here what is not true. Not true. Because some of you did this. X plus 1 squared is not x squared plus 1 squared. That's not correct. Okay? What you have to do again is this thing, which is called a special product, or in Spanish, una fórmula notable. And I'm going to explain for you where does that formula that we did here, where does that come from? Again, I don't remember if we did this or not before. So, but I'll do it again just because it's a good reminder. And then you can have it in notebook and you can have it on a video and then look at it every time you need to. Okay? So if I have x plus 1 squared, that's the same as x plus 1 times x plus 1, right? Because the square means multiply the thing times itself twice. Okay? All right. Now, I'm going to multiply this times this, x squared. This times this, plus x. This times this, plus x. And this times this, plus 1. So notice that all I'm doing is I put this as a multiplication. Then I did the multiplication, double distributive property. And then I'm going to add like terms. So x2 plus 2x plus 1. And that's where we get what we got here in black. You see it's the same thing? And again, you don't have to do all this process if you memorize what I told you up here, which again, you can go back and listen as many times as you need. Is the first one square plus 2 times these two, so 2 times x, 2x times 1, 2x, and then this one squared, always adding. Okay, and so that happens with other ones. Like if I have, for example, if I have, let's do x plus 3 squared, or let's do x minus 3 squared. Well, this is going to be, again, the first one squared, which is x squared. Then we're going to use this, which is minus. And then I'm going to multiply x times 3, 3x times 2, 6x. And then I'm going to put the 3 squared, which is 9. And so this is a very, very important thing that you need to learn. And if you learn it now, it's even easier, okay? Because it will help you to simplify expressions like these a lot faster, okay? So again, when we have a binomial square, the answer is always a trinomial, never, never a binomial, okay? This is not true. Do not do this. This is wrong, very wrong. Okay, excellent. Maybe we can do one more and then keep going another time. Okay. If you are still not very sure about that formula, make sure you go back and read and listen to this video a lot of times. Oh, and as I said, please subscribe to the channel so that it's a lot easier for us to communicate, okay? All right, let's do 9. 9 is easy and a short one. 9 says if f of x equals -1, find the domain and the range. Okay, now, again, a function is a machine, okay, that is telling that we write it like this, and that is telling us what kind of line we have and what's happening. If we think about this is just a constant, it's just -1. And so f of x, we can change it for y, so we have y -1. So if I were to graph it here is -1 in y. And so my graph of this function would be a straight line that goes horizontally and passes through -1, okay? So now looking at it in a graph is a lot easier to see what's happening. What would be the domain? What are the letters or the numbers that are relating from the x-axis? If I start on the left, because domain is left to right, range is the y's that are relating, so it's bottom to top. Okay, that's how we always read it. So who's the first one here? Infinite. And where does it finish? In infinite. So it means all the numbers are relating in x. So my answer is real numbers. Okay? Now, if it says range, is which ones are the numbers in y that we are that are relating. And if you use a piece of paper, you can cover here and see, okay, which one is the smallest y? Oh, it's -1. And which one is the biggest? There's nothing here. So which one is the only y that is relating in this case? In this case, the only y relating is -1. So my range is only -1 because that's the only one that is relating, okay? And I'm gonna explain to you really quick number 10 because that's something that you did not learn with me. You just watch the videos, and I want to make sure that we all understand what we're doing. In number 10, they give you a graph, okay? And they say that this is our thing goes like this, right? This point is -0, -1. This point is, what is it? -4, 3. And this one is 4, 3. Okay? If you can, please go to page 340 so you can see it from your book, because my drawing is not the best. But again, what they ask is to give the domain, which again is the x's that are relating, and the range, which is the y's that are relating. And what you can do, just like I grab my piece of paper here, what you can do is you're going to start here and you're going to say, okay, I'm going to start from left to right, seeing which one is the first x that relates. Which one is the first x that relates? -4. Then all of these relate. All of these x's are relating, all of them, all the way to here. What's the last x that is relating? 4. Okay? And both of those, no, actually this one is open. So my domain is going to be from -4 included to 4 excluded. Okay? And I want you to write it like this because it's easier. The book also writes it like this. And if you prefer, you can also write it like that. But these are the same thing. It's saying that all the x between -4 and 4, -4 included and 4 excluded. Okay? Whichever way you want to write it, this or this is fine. It's just different ways of writing it. Why is -4 included? Because here Negative 4 is included. Why is 4 not included? Because this 4 is not included. Okay? All right. Now the range. The range is going up from the bottom to the top. So which one is the first y that relates? Negative 1. And what is the last one that relates? 3. It's not included here, but it's included here, so I put it included. So it goes from negative 1 to 3. Or, again, if you want to put it with the y is greater than negative 1 or equal, and smaller or less than equal to 3. So that's how we do that one, okay? I hope that that helps you understand those exercises better and for you to be able to do them in the next exercises, okay? All right, we have one more minute. Can we do one more? We already did 12 and 13 in the other exercises. We did 15, also an example in the other exercise. Let's go to 23. That one is a very important one. 27, we also did an example. So if you did not do 27, for example, in lesson 82, go back to 81, check how we did it, and use the same process, even though it's a different exercise. The process is the same. Okay, so let's just do it so that we can finish lesson 82 and be done with lesson 82. Let's do 23 because I'm not sure if you guys were really simplifying this or just kind of guessing. So let's see 23. It says identify if they're rational or irrational. The first one says 3 pi minus 7 pi minus 4 pi. Okay, so we have to simplify this. Okay, we cannot say if this is rational or irrational without doing it. So we have to first do this. What is 7 minus 4? Is 3 pi. And 3 pi minus 3 pi, 0. Is 0 rational or irrational? It's rational. So I put rational. 0 is rational. Okay? So again, you have to simplify. And this is part of the process you have to show me so that I know you simplified. Because if not, it's very easy to just copy from the back of the book, which we do not want to do. We want to learn and we want to give our best. Okay, let's see this one. And this one, again, we cannot say, oh, it's irrational. It has square root of 2 without us simplifying. So let's simplify. That's 2 square root of 2. And this is 2. And that's minus 2 square root of 2, which a positive and a negative cancel. And my answer is 2. So is 2 rational or irrational? It is rational. Rational. Not irrational, it's rational. Okay. And the last one of this exercise says the square root of 101.2 minus 6/5. Okay, now to do that without a calculator, because you cannot use calculators, not yet, what you have to do is simplify that thing. And 101.2 is the same as 101/2/10, right? Because this is 2/10, there's a point there. So if I simplify 2/10, I get 1/5. So now it's 101 and 1/5 minus 6/5. And to subtract that, I need to open the box of pizza, what we do, which is take away 1 from here. So now I have 100 and give 5 to this. So now I have 6/5. And 6/5 minus 6/5 is 0, which now I have the square root of 100. And the square root of 100 is 10, which is also a rational number. Okay? Notice how all of these had process. If you did not show the process, you should not be getting any points for those because you were not supposed to just guess rational and irrational. You were supposed to determine, and to determine, you need to be sure by doing your process. Okay? All right, chicos. I think we are going to stop here. This is lesson 82. And what we're going to do is I'm going to record some other videos for lesson 83, 84, and 85. And then you guys can just watch them and answer any questions or clarify anything that you may have. Again, be responsible for your own learning. I'm doing all these videos for you, so make sure that you watch them, okay? Instead of watching other videos of whatever else in the internet, make sure you watch these things, okay? And again, please subscribe so that you can easily follow whenever we have problems like today, where we have to connect and disconnect. And I don't know, do you guys want to do you want to do some hangouts? Do a call in hangouts right now? If you want, I can call you. I'm gonna finish here and then we can pass to hangouts. Bye, chicos. I miss you guys. Continue working well. You're doing great.